So we're going to finish this video series up by taking a look at some of the questions that you might be asked to be able to respond to based on the plots. Right? Some of them are going to be really easy. So first of all, we want to define the explanatory and define the response variable. Well, that's easy because we already just did that earlier. So if I was to answer this, and you're going to do this in a Word file, but I'm just doing it here so that way we can just have one screen and not flip back and forth. The answer to one is going to be that the explanatory variable is the team payroll, and that should be able to predict the win percentage. We already did number 2 as well, define the strength, direction, and the association. So we know that we have a linear association. We know that it's positive, but it's a moderate to weak association. Interpret the correlation coefficient. Well, 2 things that we can say is that it is a positive direction. And the other thing that we can clearly see is that it is going to be a moderate association. And I believe we said that if R is between 0.3 and 0.6, that we were 0.5, so 0.3 and 0.6, something like that. All right. That's going to be a moderate association. All right, but 0.4 clearly is going to be moderate. All right, so moderate association since R is equal to 0.4 something or another. I can't remember what it was exactly. It was up here, 4402. Okay, so we just say 440. Right. Are there any outliers? Justify the response using the residual plot, and the box plot. So we look at the residuals. The highest and the lowest that we have are going to be, and I'm going to highlight them. This is the quote highest number, and then the quote lowest number is going to be right here for the residuals. So we look at the residual plot, and although they are pretty far away, these might be suspect. And the only reason they're suspect is because they are the farthest points. But if we look at the residual plot, not necessarily all that much further than some of the other ones consistently. So there's 3 right here. This is the only one that really looks like it's suspect because it's so far away from all the other negatives. However, we look at the box plot, and the box plot suggests that there are no outliers, all right, because there's no dots, if you remember in the previous video. All right, so for number 4, we do have these suspect variables. So these are suspect. However, the box plot does not indicate any outliers since there are no data points beyond the whiskers. And then finally, if we want to overall summarize the association between the number of wins and the payroll, so what can we summarize? Well, we can kind of say that if you spend a lot of money, you can reasonably expect to win more games than teams that don't spend money. All right. However, that's not always the case. Clearly, right down here, the Tampa Bay Rays, who had the lowest payroll in baseball, actually had one of the highest win percentages. All right. So if you look at the winner percentage, they're only behind teams like the Minnesota Twins, who also spent a relatively low amount. They're in the bottom half. And then, of course, there's the Yankees, who spent almost more money than anybody in baseball and did have one of the highest winning percentages. All right, similarly to the Astros, who spent a lot of money and had the highest win percentage in baseball. So it's not always true, but if we look up here, we notice that, okay, well, all these teams with the highest payroll are at least above 0.5, which means they won more games than lost. All right, the Giants, for some reason, they just lost. But then down here, so it looks like almost all the teams in the top 10, all but 2 of them, won at least 500 or at least 50% of their games. And then as you go down a little further, then it gets a little bit more sporadic. Right, the Indians won a whole bunch of games, even though despite they only had 0.1 or $100 million payroll or $110 million payroll approximately, athletics completely shattered winning percentage expectations, etc. So did the Rays. So it doesn't necessarily always suggest. So what we can say is that there's a reasonable expectation that the more money or the higher the payroll may lead to a higher winning percentage. With any analysis, this is simply a cross-sectional analysis. So what we'd probably have to do is we'd have to look over a number of years to be able to determine an association. All right, so there's n equals 30, which is relatively small. All right, and also the study is cross-sectional study. And of course, cross-sectional studies are certainly less reliable than our cohort studies. So what we probably would want to do is go back maybe 20 or 30 years to determine the patterns overall. And based on that large sample size, almost population, if you would, then we could really make a better conjecture about the association between wins and payroll. Although realistically, we would expect that to be true. All right, so this is a cross-sectional study. They wish to use a cohort study. Cohort study always better than cross-sectional if available. All right, so hopefully this helps you to be able to understand how to answer the questions, to use the graphs, and then to also how to do the mechanical parts of working with bivariate data.